All right, so we're plugging in our theta. When you plug 0 into theta, what is the cosine of 0? 1. So you have 2 plus 2 times 1. So what do you get? 4. Okay. Let's plot that point on our graph. Yes. If you can wait a minute, I would. Like, at least see one whole graph so that you can see it. Okay. All right, so remember when we plot these, I know we had listed it with the theta first and then the r, but find the radius and then travel that angle. So my radius is 4, so 1, 2, 3, 4, and then my angle is 0. So dot goes right there, right? Okay. All right. The next point I'm going to pick is pi over 2. You're just doing the easy ones around your circle here. So what happens if I plug in a pi over 2? Now, what's cosine pi over 2? 0. So what do I end up with? 2. So let's plot that. So over 2 and then around to your pi over 2. All right, then I'm going to plug in pi. What's the cosine of pi? -1. So 2 plus 2 times -1. What do we get? 0. Okay. So you go 0 and travel pi. It doesn't really matter how far you travel. You're at 0. You're like at the pole. Okay. All right, 3 pi over 2. Again, guys? Yes. So you go to 2, go all the way around, you're down there at the bottom. What do you expect to get when we plug in 2 pi? Yeah, you should get what you started with, right? 4 again. Okay, so those 4 dots look like that's not really enough to guide your shape here. What you're going to learn today is there's 4 different types of nuisance. There's an inner loop, a cardioid, a dimpled, and convex. So you can plot 4 points, and then recognizing the patterns in the equation, you'll be able to draw the shape. So this is actually a cardioid. What do you think a cardioid, what shape is that going to be? A heart, yes. So.
Oh, like cardiac.
Yep. Exactly. Okay.
Look at how good Hardy is. Give me that. Give me that. Right now, only through with it. Just for you.
All right, if you look up here, this r equals 2 cosine theta. We always have a formula, r equals a, and then it's either plus or minus b sine or cosine theta. When a equals b, you guys see how we had a 2 and a 2? Can you read that up there? When you have a equaling b, that gives you a cardioid. Okay. This one was a cosine. Do you guys notice how the heart is mainly on the x-axis, the cardioid shape? Okay. So if you have cosine, it's going to be symmetric to the x-axis. Means it's a cardioid. We're going to have other things like a is greater than b, a is less than b, that sort of stuff. So if a equals b, it's a cardioid. Okay. The other piece we have there, since it's a plus in between, you are drawing on the right side of the graph. Does that make sense? Most of it is on the right. All right, so let's look at our second one here. We have r equals 1 plus 2 sine of theta. Is that going to be a cardioid? A is less than B. Okay. So we're going to make our little chart again. So let's plug in 0. What do you get? 1. And let's plot. Go over 1. Angle of 0. Okay. Let's plug in pi over 2. What do you get with that? 3. All right. So count out 3. Travel around pi over 2. Plug in pi. What do you get? 1. All right, plug in 3 pi over 2. What do you get? -1. Okay, so let's think about graphing this just because we have a negative. When your r is negative, remember you go left first, and then you have to travel around 3 pi over 2. Okay, so I'm over here, so pi over 2, pi, 3 pi over 2. My point is actually up here. Is it a rocket? No, it kind of looks like it. You can plug in 2 pi if you would like. You're going to get back to what you started with 0, so you're going to be at 1. Okay. This one, we had A was less than B. That is called an inner loop. So the way you draw it, whoa. They definitely will cross right here at the pole, so you're going to just come a little past, and then you'll go forward and you do your loop. Okay? So that will help you. There's what? Yes, guys, if you want to just see it happen on your calculator, turn your calculator on, go to mode. Oh my God. Take the polar. There's going to be sections of each. So some of the graphs you're going to have to do on your own. There's some matching. All right, so change your mode to polar, and then when you go to y equals, it's no longer going to say y equals. What does it say? R equals. And if you push the key you would normally push for x, it's not going to give you an x. It's going to give you a theta. So go ahead and key in 1 plus 2 sine of theta. And guys, with your mode, what else do you think we should be in? Should you be in degrees or radians right here? Radians. Yeah.
Wait, sorry. You said R?
R equals 1 plus 2 sine. When you go to your y equals, it's not going to say y equals anymore if you've changed your mode. Polar. See it? Polar, yes. Anyone not seeing it on their calculator? A. And this could be sine, it could be cosine. Okay, that's just going to determine x and y axis here. You'll like it when we get to the roses and it'll draw all the petals.
So like, how to look at it, there's no way.
I know you never.
Oh, there we go.
It's like, could you explain what you have? So I up to
So go to -1 first, which is left. Like you start here, then, and then you have to count around 3 pi over 2. So there's pi over 2, there's pi, there's 3 pi over 2. Okay, so it's still that distance, it's just you're starting from a different point. All right, guys, let's go back. I just want to jot down a couple of other things. Guys, this one had a sine in it instead of cosine, right? Which axis is it symmetric to? Yes. And it was a plus in between, right? So that's why it's going up on the y-axis. If it's negative in sine, it's going to be going down on the y-axis, okay? All right, so far so good? Okay,
Wait, so you don't need to worry about the top thing for like the movie.
no, you don't have to do that at all. You can like graph the sine or cosine wave the way you used to, and then you can like transfer it here, but it's a lot harder than just plotting the points, I think.
Is there any like pattern? Like,
Yes.
for example, like you go like touch one.
You'll see it. It takes a little practice. All right, so let's do this one. Here's your equation. R equals 3 plus 2 sine of theta. All right, so A and B, are A and B equal? Is A bigger than B? Okay, A is bigger than B. So, let's make our little chart. So theta, R. Which axis are you guys expecting this to be symmetric to? The Y.
Why?
Yep. And do you think the graph's going to be up or down? Okay, good, good. You guys are catching on. All right, so let's figure out our points. If I plug in 0 for theta, what do I get? 3. What about when I plug in pi over 2? 5. Oh, we should plot, sorry. Okay, what about when I plug in pi? 3. What about 3 pi over 2? 1. Again, you can do 2 pi, but you'll be back where you started. Okay. All right. So our A over B, or our A was greater than B. We're going to look at the fraction, actually, of A over B here in a minute, but I'll just give you the name of this one. This one is called dimple. Okay. Sort of. There's 2 that when A is greater than B, so I'm going to show you a quick way at the end to recognize all 4. These last 2 we're just going to kind of leave alone until we've got them all done. Okay. So what dimple looks like just sort of dips down just a little. Okay. Kind of a weird looking, like, too fat of a heart, sort of. It's got a dimple. And so again, since we had sine, we knew it was going to be symmetric to the y. And since it was positive, we knew it was going to be up. Not too bad. Both of these 2 have the fractions we talked about. And then I'll actually write all 4 of them in that way, because then it's a lot easier. There's a progression where you can think about like inflating a balloon. And it's easy to remember then what you're doing. So. All right. Are we okay with the third one? Okay. So if we look at the fourth one, again, A is bigger than B, right? But A is kind of a lot bigger than B. So this is actually a different one again. This is your fourth one. So let's plot our points. And just looking at it, what axis is it going to be symmetric to? X. Do you think it's going to be mostly on the right or the left? Right, good. Okay, if I plug a 0 in, what do I get? 4, good. If I plug pi over 2 in, what do I get? 3. If I plug pi in, 2. 3 pi over 2. 3. And then you can stop there if you want. So what I want you to look at, when we did this dimple one, this point where the dimple is, do you see how it's just one away from the pole? Okay. This one's not going to be dimpled because do you see how much farther away from the pole it is? Okay. So this is actually called convex. Sometimes it's called flat. So I would take either of those. So when you draw it, it sort of like flattens out at that point. Comes back around to that. Do you see the difference in the shapes between those two?
Do you ever like know what it is?
So on your test, there's a matching section where I'm going to give you like 10 equations and 10 graphs and say which one is which. Is that kind of what you're asking? Okay. All right. So we've got 4 different types of lumisomes. Let's go through the way you remember what they are. So if we actually think about the relationship of our A and B, you remember the first one, A and B were equal? Well, let's do a fraction out of that. So if A and B are equal, what is A divided by B? Okay, that was our second one, wasn't it? Sorry, guys. Because first we had less than 1, if you thought about it. Wasn't A less than B on our very first one? Okay. And that was our inner loop. Did I do them in a different order? I think I did. Yeah, because we did cardioid first, right? Okay. So you guys jot all of these down and then I'll explain them. And if we have our A over B is between 1 and 2, we had our dimpled. And if your A over B is greater than 2, that's when you have your convex. So if you think about the shapes of these, actually I'll give you guys a second to write and then you can watch the shapes. So you're going from less than 1, equaling 1, between 1 and 2, bigger than 2. Do you guys see how that like puts them in order? Okay, if you think about the shapes, an inner loop. Yeah, that's what it looks like. That could be a very deflated balloon, right? Okay. Sure. If you blow it up a little, then it becomes a cardioid, right? If we add more air to it, it's just got the little dimple now, okay? And then when you put too much air in it, it becomes that like flat convex shape. And those are terrible pictures, but
I got it.
does that help like connect the order? So like smallest to biggest on the left, balloon order as well. Will that help you remember that a little? Okay. So for your practice right now, definitely still make the little chart with your R and your theta, just to make sure you guys have the points right. Eventually you're going to get to a point where you recognize what it looks like, but right now you still need a lot of practice graphing it. I'm going to give you some graph paper here, some polar graph paper, so that we can do some practice on this.